When it comes to peptides, few are as popular as these two. BPC-157 and TB-500, better known together as the Wolverine Stack. They're claimed to dramatically accelerate healing, even earning comparison to Wolverine himself. But despite the hype, the results seem to be mixed. So in this video, we're breaking down the actual science, what these peptides are, how they might work, and whether they live up to the claims. I've also run this stack myself, and I'll share my personal experience at the end of this video. So, let's go. Okay, so what is BPC-157? BPC-157 stands for Body Protection Compound 157. The 157 refers to the larger protein it was originally derived from, which contained 157 amino acids, although the peptide itself is only a short fragment of that protein. So BPC-157 is a synthetic peptide derived from a larger protective protein, which is naturally found in human gastric juice. So to be clear, there is no naturally occurring molecule in the body called BPC-157. The stomach produces a much larger gastric body protection protein, which is, like we said, 157 amino acids long, and researchers isolated a small region of that protein, a 15 amino acid fragment, that appeared to retain repair signaling properties of the main protein. That fragment was synthesized in a lab and given the name BPC-157. So to summarize, naturally we have a large gastric protection protein, and synthetically we have created a small stable fragment of that protein called BPC-157. One might wonder, why use the fragment instead of the full protein? This is because in peptide drug design, researchers look for the smallest segment that keeps useful signaling while removing unstable or unnecessary portions. Smaller fragments are also easier to manufacture, more stable, and often more practical biologically. So what does BPC-157 appear to do? In animal research, it is associated with modulation of nitric oxide pathways, stabilization of blood vessels, which means it protects and strengthens existing blood vessels so they remain intact and functional, angiogenesis support. Angiogenesis is the body's way of growing new capillaries to supply oxygen and nutrients to tissues, inflammation regulation, and tissue protection under stress. So that is what BPC-157 was observed to do in the animal studies. It appears especially active in tendon-bone junctions, ligaments, and of course gut tissue. It's also unusually quite stable for a peptide. This includes oral stability in gastric acid, which is rare for a peptide. Now we need to highlight that BPC-157 is not FDA approved, nor EMA approved, which is basically the European version equivalent of the FDA, and not approved as a medication or supplement. It remains a research peptide due to lack of large human clinical trials, and not because of proven harm, but because adequate human data does not yet exist. What is TB-500? TB-500 is related to a naturally occurring human peptide called Thymosin Beta-4. Thymosin Beta-4 is a 43 amino acid long peptide found throughout the human body. It is found in platelets, immune cells, muscle tissue, endothelial cells, and more. It plays a role in wound healing, angiogenesis, inflammation control, and cellular organization. Important to note that Thymosin Beta-4 is not a hormone. It is best described as an intracellular regulatory peptide, specifically an actin binding peptide. Okay, so what is actin? Actin is one of the most abundant proteins in the human body. It forms the cytoskeleton, which is the structural framework that gives cells shape and allows them to move, divide, and repair tissue. Important to note that cells are not static. They constantly remodel their internal structure, and that remodeling depends on actin. There are two forms of actin, G-actin and F-actin. F-actin, thymosin beta-4 binds to G-actin in particular. These are the building blocks of actin filaments, and TB4 prevents premature polymerization. So let's start off by explaining what polymerization is. Polymerization is the process where small individual units or monomers such as G-actin join together to form a larger chain or structure called a polymer such as F-actin. So to reiterate, G-actin, which is a monomer, is a single building block. F-actin, also referred to as a polymer, is many blocks linked together. Now, what is premature polymerization that TB4 actually prevents? Premature polarization is when actin filaments start forming when they're not supposed to. In other words, G-actin starts assembling into F-actin too early, in the wrong place, or without proper control. And why is this a problem? It's because cells rely on tight control of actin because it affects cell shape, movement, for example, muscle contraction, cell migration, internal structure, which is the cytoskeleton, and wound healing. So if polymerization happens too early, filaments form in the wrong location, the cell loses structural control, and movement becomes inefficient or chaotic. So when tissue is injured, cells must migrate, change shape, and reorganize. That requires precise actin control. And in summary, thymosin beta-4 helps regulate this entire process. TB-500 is a synthetic fragment inspired by thymosin beta-4 biology. It does not fully replicate the endogenous peptide, but it aims to emphasize repair-related signaling similar to what we see with BPC-157 and its parent protein. Also worth noting that from what I observe on the peptide market, the popularity of TB4 is starting to take over that of TB-500, as this is now also available for consumption or research purposes. Okay, so why do people stack BPC-157 and TB-500 or TB4? This comes down to how they appear to complement each other. BPC-157 seems to work more on the environment, supporting blood flow, protecting tissue, and modulating injury-related signaling. TB-500, on the other hand, seems to work more on the cells themselves, especially things like actin, which affects how cells move and physically carry out repair. So a simple way to think about this is BPC helps create the right conditions, while TB helps cells actually execute repair. That's essentially the idea behind what people call the Wolverine Stack. Okay, so what does the science actually show? Most of the data we have on BPC-157 and TB-500 comes from animal studies only, typically in rodent and rabbit models. And importantly, these peptides were studied separately and not together. But what's interesting is when you look across these studies, you start to see overlapping outcomes, such as faster tendon and ligament healing, improved muscle regeneration, enhanced blood vessel formulation, and overall better tissue repair. And when researchers look at the underlying mechanisms, they see things like increased angiogenesis, so new blood vessel growth, greater fibroblast migration, key for tissue repair, improved collagen organization, and modulation of nitric oxide pathways. You also see similar patterns across different types of models, whether it's nerve injury, gut damage, or vascular dysfunction. But again, this is all animal studies. Human data is still limited and we don't have large-scale clinical trials yet. Now, of course, that doesn't mean these compounds don't work in humans. There are plenty of anecdotal reports stating that they do. But from a scientific standpoint, the level of evidence is still far below approved pharmaceuticals. So remember, there is a big gap between something being biologically plausible and being medically proven, unfortunately. So what are the risks and unknowns of the Wolverine Stack? Okay, so any compound that influences things like angiogenesis, which is blood vessel growth, and overall cellular activity, deserves a level of caution. There are still a lot of unknowns. Here we're talking about long-term effects in humans, lack of standardized dosing, variability in product purity and sourcing, and the possibility of unintended effects from increased angiogenesis or long-term use of these peptides. And the key idea here, just because something speeds up healing doesn't necessarily mean it is optimal healing. And more importantly, when you're dealing with unregulated compounds, you're also dealing with inconsistency, which means that different batches from different sources can have different outcomes. So while the mechanisms are interesting, there is still a lot we don't fully understand. So who uses the Wolverine Stack? Most commonly, you'll see them being used for things like chronic tendon injuries, ligament issues, muscle tears, joint pain, gut-related support, and recovery during more intense training phases. But this is where some people get it wrong. These peptides aren't replacements, but they can potentially be add-ons. They can be added to the fundamentals and not replace them. Here we're talking about sleep, nutrition, rehabilitation, and load management. If those aren't in place, nothing else really matters. Because at the end of the day, there is no peptide, no compound, nothing really, that can fix poor fundamentals. Okay, so to conclude, so where does this leave us? BPC-157 and TB-500 or TB-4 are biologically fascinating. Mechanistically, they make sense. The preclinical data is quite compelling, and anecdotal reports are everywhere. But they still exist in a gray zone, unfortunately, somewhere between promising biology and incomplete evidence. And that distinction is something one should be aware of. Because if you're considering anything like this, education should ideally come before enthusiasm. Now, with all of that said, let me share my personal experience. So I first started using BPC-157 and TB-500 around 2 years ago. This is where I was dealing with a pretty serious back issue. I was never formally diagnosed for the issue, but I did see an acupuncturist that helped me with the severe pain and who also suggested it could be something like a slipped or herniated disc. Of course, at that point, I implemented multiple things at once, and the so-called Wolverine Stack was just part of my new protocol. I was also making a lot of lifestyle changes, using an inversion table regularly, becoming much more aware of my posture and how I was sitting day to day, adjusting the way I sat and incorporating a lot more stretching and hanging. On top of that, I was also using other compounds like human growth hormone, as well as a range of supplements to support the recovery. And honestly, it's very difficult for me to isolate the effects of the peptides, or say with certainty that BPC-157 and TB-500 were the reason things improved. What I can say is this: over time, my condition improved significantly, and today it is in a much better place. More recently, over the past 6 months or so, I've been using a different combination, often referred to as the Glow Stack. This includes GHKCU, TB-4, and BPC combined. And that is something I might break down in a separate video. Alright, so if you found this breakdown useful, please let me know in the comments. Have you heard of the Wolverine Stack before? Have you actually used it? Are there other compounds you want me to cover on this channel? Let me know. Thank you for watching, and I'll see you in the next video.